if we talk about the open source streaming data ecosystem, there is a lot of open source streaming solutions, which was not always the case in the past, right? Things have changed, and we'll go through that. And all those solutions, they have pros and cons, and they solve specific problems. So the goal of this entire session is to discuss the various ways that businesses blend those open source solutions together to solve specific business problems, and to clear things up for everyone on the show. So it's really not a live show about the Lenses technology, but really a more broader view on the open source data streaming ecosystem. Before we start, I'd like just to touch on upon just the history of it. Because if we think about it, like 20, 25 years ago, maybe 30 now, time's passed, most solutions were made out of enterprise software. And more, like 15 years ago, there wasn't like an explosion of open source solutions. Can you touch a little bit up on that?
Yeah, for sure. And that's fun because all this start with a talk in London that I have been at, and we are discussing actually like this, why open source solutions into data, specifically in this case, has been this boost, has been this great stuff. So the whole idea, in my opinion, is initially data solutions start to have more like a core participation in company. If you see big companies now has data solution as a principal product inside it. And one of the things is you have I believe there are two main reasons why this is happening. First is the flexibility lock-in. Companies nowadays, they don't want to stay to one vendor, they want to stay to one place. They want to have the capability of have a complex solution if the business needs to. That's one thing that's, I believe, will happen. And the other things is the power of the community. So you have the entire world working with you for features, working with you to solve problems. It's more like we see communities of every type of technology. They work together to go. They have similar problems because companies have similar problems. They have different business cases, but they have similar problems. So maybe one feature can solve like hundreds, thousands of problems that can boost other businesses. So we see more about this. And yeah, I think it's more this too, like the community and flexibility. I think that's what gained powers for open source over the other ones. And let's be honest, most of the enterprise solutions that we have today, they are in the backbone. They are like the core solution is open source. So at the end of the day, you're using open source or not, but they're using open source at the end of the day.
But yeah, there's been a big shift, that's for sure, right?
Yeah.
A huge shift. And now maybe is it the right time maybe to dive in, maybe a first architecture or first blend of technology, open source technology we see for data streaming? Is it the right time to jump in it? Okay,
yeah, it is. Let's start because I know that people want to know about.
Yeah,
they want to know about technology. We are technicals.
So I believe, Mateus, the way you present it is maybe from the most used ones, or no? Is it classified by in any way?
Yeah. Good question, Simon. The whole idea is we have a lot of technology, so not have time to go over all of them. So the whole idea is to talk the most used one, the most that people are talking all the time. They'll be talking to customers. The customer is, okay, we have this technology inside. We're using this, we're using that. So we're trying to bring the ones that can be for small companies, but can be for big companies as well. And I always try as well to think of not only this, but what it can be easily being used for event-driven systems, using for all use cases that we have. Because again, companies will have a variety of use cases. But yeah, that's a good question. So let me start to explain this. So don't be afraid. The whole idea is we have this common pattern that we see in the lives, that we see in the companies. We have event-driven systems producing data inside Kafka. So each box here is a type of data that we have from the CRM system, RP system, microservice AB. There's no push name because it can be any business, again, HR or something like that. But then we have the data on Kafka. And then someone says, okay, now I want to join streams. I want the box of blue, the box of purple to be joined. I have a key and I need to join both of these streams. Or I need to do aggregations, or I need to do enrichment. I want to actually, my RP information, my stream is coming, but I want to access an external data source, can be a database, can be a file, whatever. And I want to enrich that stream and go back to Kafka and to the downstream applications. So these use cases, we see a lot of this guy has been used. Flink as a process engine. And one of the things that I have been noticed since Kafka Summit of last year is everybody's talking about Flink. Everybody's talking about how to use Flink as a process engine for streaming, because Flink was born to work with streaming. So most of the process engine that we have today, they start as batching. For example, the most used one in the market is Apache Spark. They are born in batch, and then they receive like Spark streaming, then receive structured streaming, then receive some improvements on the structured stream. Flink was born to be streaming. That's the completely different thing. And I'm gonna say that has a lot of pros and cons. I'm gonna just elucidate a few of them. Then we're gonna show the capabilities of each tool so you guys can choose in the daily basis. So it's wide battle tested. Alibaba used this in China, so has been trillions of events being processed by Flink, so we know he can handle the workload scale as a petabyte scale. I can develop in SQL, Python, and Java, which open up again for not only for Java developers to create these streaming applications to process data, but for data engineers to know Python, for data analysts to know SQL. And he can handle both stream and batching. So I can have, okay, I want you to batch now, I have Flink to use it.
Mateus, so the shortcut you're taking here is when you show Kafka in the beginning, you assume people understand why we use Kafka, and we as a global technology community path from direct connection between consumer and producer to event-driven application, and then using Kafka to decouple of all of that and all that fun stuff, and then Flink to make it easier to transform. Because back in the day, you had to actually develop your transformation, and it could be complicated, could take a lot of time, and so on and so forth. So I just wanted to clarify that right? So Flink just comes to lower complexity to users to transform data using SQL, right?
Exactly like that. Not only SQL, but Python as well, because if you take like the Kafka ecosystem environment, you have the Kafka streams, but you have to develop applications in Scala in Java. And again, most of the data engineers of nowadays, data analysts, they don't know about Java and Scala. They go with Python and SQL. So this open up more to process data, to shape data as you like, using different programming languages, which can be like, again, is a completely no. I consider Flink as a platform, not only as a process engine. I go even more broad. I go to as a platform because, again, you can use different languages. You can work with different. It's just the tip of iceberg. Because if you delve into Flink itself or the technology that we have here, we need at least 1 hour session for each of the technologies so we can explain in a nutshell, yes, everything about it. So even they are huge, they have a lot of complexity. But what we can take from here is the main reason to use Flink is to process data in stream. So you can access the data for join, for aggregation, enrichment. You can have this case when I can have my stream coming from Kafka and I want to change it. Again.
So one of the business driver for this first blend of Kafka and Flink is maybe you have a pipeline that is using batch in batch mode and you want to be in real time. So then you would use both Kafka and Flink to solve this, to put on this new service, for example. That would be a use case, right?
Yeah.
So what are the cons then?
Yeah, because not everything is good here. So first, you have the whole infrastructure to maintain. It's like I said, you have a separate deployment, you have to monitor, you have to see everything is the Flink job is running. You need experts to use these new platforms. Not handle again, you can programming things, but you have to have an expert to properly use the tools. In most of cases, Flink can be a bazooka to kill like ants. So you don't need to use this like the whole infrastructure complexity. If you need to do something simpler. So if you do I need to do a simple join, I need to join a few topics. Again, we're gonna have the whole infrastructure to worry about to do this. So depends of the use case. I always think about the use case. My use case, like more broad, I have to do a lot of transformations. I have to handle this. I have really complex, and I'm gonna talk about a real complex use case that I need to use this. Okay, makes sense. But no, yeah, I'm just make a few transformations, maybe some filtering, maybe joins. Maybe you can think about other solutions for that. And for Flink, we still have majority of the features in Java, Scala programming. So again, we have the SQL and Python, but majority is still for Java and Scala. Okay, so let's go to the number 2. So far, so good, Simon?
Yeah, so far so good. I understand it's not all nice, right? The cons are pretty important. Be sure that your business use case is big enough to be worth the extra work. If it is, then it could be a good fit. Yeah.
Yeah, and
don't underestimate the expertise needed in the team.
Yeah, and the highlight is here we're gonna show a few technologies for you guys to or not using now, but I think to have a use case that can use, go to the documentation, try to read more about it. It's just a glimpse because again, it's 20-minute session, so we can give everything in 30 minutes. But it's for you guys to see the use and then think of. The same scenario, data coming from Kafka, but now I have to do this. I want to access that data in low latency as possible. Huge amount of data in low latency. I want to have the high concurrency, and I want to do query, analytical query. I want to do aggregation. I want to do group by. I want to order my data that I want to do. And that has to do fast. I have to do fast, analytical, with millions of users is access that stream in the low latency as possible. So what I have here for you, Simon, is just 2 guys, Apache Pinot and Apache Druid. They are OLAP systems. They like, I consider them, that's a personal opinion here, as data warehouse for real-time systems. So if I want to have this for streaming, I can use these 2 guys. The best part of them is they're using as consumers. So they access the data in Kafka and then they push the data for their storage. You don't have to create a connector, or don't have to do anything in the middle. He's responsible to access the data in Kafka and bring it to you. After he does that, all the magic started. Again, queries I see, I'm gonna say like in cons here. I see they run queries in billion rows, like in seconds, handle many connections, like it's connections, millions of connections, huge workloads, for example, use it, Walmart, Stripe, and Target use this. Imagine what's the volume for them to deliver analytical data. And the best part is most of them like the perfect match made in heaven for Kafka. So if I want to query data for Kafka, because we know that if we go to the Kafka, we can read it, but we partition 0, 1, 2, 3, and then my application has to compute this because get all data, and then, okay, I want to filter. I have to compute everything that is my topic, and then I have to computation. Here, I have a different way that I'm not going to answer too much, but it's a time-based out of the database.
And just for everyone on the show, the OLAP system, of course, is a database. It's a column-based database, right? Basically, is that a good way to summarize it?
Exactly.
Yeah. So why Apache Pinot and Druid? How is it different? It's born with Kafka. Is that what you also said? That it can consume from Kafka natively.
Yeah. The whole thing is they don't need to do a connector to do this. Most of the data warehouse you have to connect with the connector to push the data from Kafka into the data warehouse. In this case, no, they go as a consumer and they keep consuming the topic. So it's reactive. You don't have anything in the middle to do it. So after this is all about how the architecture inside works, but they all work pretty similar in that part.
So that seems all good. Is there any cons? Because I
yeah, unfortunately, no, we have. First, I say about maintaining in Flink is something infrastructure, but these guys, they have a complex infrastructure because they have a lot of components to do it. So it's like a complex infrastructure to handle. You need to have a timestamp column to bring the data into these two data stores. So if I don't have it, for instance, I have to manipulate my data to have one using the timestamp of the message to do it. Again, it's by choice, but I need to have a timestamp column to access the data. So most of the time I have to shape this in my event. Again, I always go to this way. I'm going to show you guys the most used for terabyte and petabyte scale. But if your case is simpler, maybe you don't need low latency. Maybe you don't need to have millions or hundreds of thousands of connections. In that, maybe you can go to another data warehouse technology, a simple one, or even a database to handle this. Again, let's always think how we're going to use it. You're going to use it for 5 years. It's going to be still, I don't know, 100 gigabytes of data, then projecting for 5 years. So maybe I'm gonna consume all this.
In terms of business need, you mentioned the Uber, but basically, company would think about this architecture when they need to provide real-time analytics to a lot of people, like in the Uber app or something like that?
I always think that if I want to go to Pinot, it's a lot of access. I need to have the freshness as soon as possible, low latency. And I have cases that databases cannot solve. I cannot run, for example, I'm going to explain more, but I have the cases of using Pinot specifically, that a customer that I have in the consultancy, he has more than 1 billion rows, 1 billion and 2 million rows, if I'm not mistaken, 200 million rows. And he cannot run this in the database that he had. But when we offload everything to Kafka and then everything to Pinot, when he starts to see is he could run this in 9 seconds. That was fun because
but the data
CEO was say, okay, change the query. They thought it was in caching, but it was not caching.
Okay, so performance is very good, but still you need a timestamp. It has to be a time-based information. Otherwise, so it wouldn't fit every use case. Okay.
Yeah, exactly. And the last com is most of these technologies, and both of them, they are not completely sequencing. So they don't have the completely SQL surface of syntaxes. They are close to have, but they don't have everything. So if you have something that you need that is not on these technologies, most of the time you're going to have to use a complementary tool for query engine. Again, you're going to add more complexity to the pipeline. So you have to think of about it. So far, so good. We're going to try to speed up.
All right. So we've seen analytics. We've seen transforming the data. So what's next? Oh, sorry, Guillaume, go ahead.
Yeah, hi, Matthias. Yeah, yeah, really interesting. Out of those two, Pinot and Druid, is it a case that one of the two will not survive in the community? Which one's gaining more adoption in the open source community? And is there a chance that actually one of them dies, a bit like what we saw with a lot of open source technologies? Is there space in the market for these two?
Yeah, that's an amazing question. I worked with Druid 3 years ago, like 2 years extensively. And we start to work here in the community that I work with because a few things. First was built in LinkedIn, the same place that Kafka was built. The second is his cloud native. And the third, I think the most important one is a community is real life. It's always happening something, is always having some, the same as Druid have as well, because Druid already start to have this, but Pinot is always have something, always have a bug fix, always have like a change. So I always go to the ones that's more, have this boost. Okay, we're gonna push more community-driven product first, and then we go to the manager. Because of them, they manage it as well. They all have the many solutions as well.
Yeah.
But it's not
both are heavily adopted across the community, though, as I understand it, right? So they're not immature technologies.
No, it's not something that I would not, for example, if something using Druid, I'm going to go change for Pinot in otherwise. I think that they're using one of them, they're probably very happy with the results. But I always going first when I'm trying to choose a solution, I always go to the community and see how is the acceleration. of the product itself. You have like meetups, people already talking about it, content, internet, and again, bug fix and new features. I think that's the most important one. Good. Amazing.
All right, for the sake of time, let's jump to the next one.
Yeah.
And I see, yeah.
Yeah. And then we have the same solution that, okay, I don't want a data warehouse. And I see there's a customer one time. I don't want to have a database or a place when I want to store my data. I want to query data analytical way, and I want to integrate with Spark, Trino, and Python. I want to integrate with other technologies as well. This is one of the guys has been talked all over the Kafka Summit this year. It's Apache Iceberg. And not only in Kafka Summit, in every data summit that I have been, event that I have been watching, it had at least 1 or 2 sessions about Iceberg integrating with something. So Iceberg is a data format when you can do queries inside of a file. Using a Hive meta store for now, but it's going to be changed in the upcoming releases. But it has all the algorithm intelligence to have time travel, to have a mode. It's like a table in the format of a file that is extremely performatic. It's building Netflix, so cost effective. If something delete your database, your table, you can time travel and access the previous data. If you overwrite the information, you're going to have historical, you can go back and time travel. It has been used for a lot of technologies. Dremio, Snowflake, you name it. Spark has been using, again, has been using for almost big technologies of data, and it can be handled terabytes of data. For example, Netflix, we participate on a podcast with one of the engineers in Netflix. They have in a single table terabytes in the Iceberg format because again, it's Netflix. Imagine how much data they have for analytical. But I get the feeling that we have only 3 cons that I think of. Again, if someone sees this and have more cons or more pros, please comment on this video for us to see as well, because it's like a personal opinion that we talk between the team. So for this one, you need a query engine. You don't need a data warehouse, but you need something to query the information inside the Iceberg table. Extra infrastructure. If you're looking for millisecond latency, maybe if you think of another solution, as we say, or ClickHouse or another one, because this, again, you're going to dump the file into the storage and then have the file itself. So for millisecond latency, maybe it's not ideal to use it. And the second,
is it like a S3 you need to flush or something like that?
Yeah, you have to use a storage for that. You can use S3, you can use web storage, you can use GCS. But the whole idea is a file. You have to push this in the file. It's a file format. You can use Parquet Avro. I forgot the other word, but in my mind now, you can use the extension of Parquet and Avro in my mind.
But but it doesn't come with a query engine.
Yeah, exactly. That's an extra infrastructure. You don't want that warehouse, but you have to use something to query that. We don't want the
package. So again, you need expertise, time, you name it. Okay, so you really need to have a solid use case to justify all that.
And you need to sync that data from Kafka to Iceberg format. Nowadays, we only have one connector so far. So internally, with discussion about this in the Kafka Summit, we have requested. So it has been the roadmap that we have in the Stream Reactor Iceberg connector. But so far, we only have one in the community. So when I say that, always that I think is, if I have one, I have none. If I have 2, I have 1. So always think about this. If I have one option, actually I have none option, because if something fails, something gives some problems, I'm like, no way to go. But if I have more options, okay, good. If something happened here, I can migrate to this place. So I always think about this as well when I do architecture, when I do projects as well. I think we should stop here, because if I go much further, we're gonna have 1 hour session.
Well, it's a multiple live stream topic, I would say. So we'll touch upon real life use cases and maybe dive a little bit deeper into other architecture maybe later on in future live stream. But yeah, thank you, Matheus. I think it's valuable. I hope the viewers and the people in the Zoom like that. If you guys have questions or real life example as I mentioned in the chat, just, yeah, please do send them. And yeah, so thank you, Mateus. I think we are not done talking about neither of those three. Iceberg may be one of the hot topic as well. Before we close the show, oh yeah, you want to say something?
No, just for some, if you guys was watching, want more about the rest that we've been talking to, please comment that you want a second part so we can know that we can continue this one, because it's like a test. It's like what we brainstorm to have this one. But Simon, thanks again, amazing hosting. You can.
But I think as a takeaway, there are three in the pros and cons. It's always the yin and the yang, but there is also something that we didn't mention is that sometimes open source, they have this curve, this usual curve of being hype, and then
they have the hype.
And so it feels to me that NiFi has gone through this curve, for example. So when you select a technology, you really cross finger that it will survive over the years so that it's all maintained and so on and so forth. So picking the right one is always, or being very flexible and being able to adjust is pretty important. Yeah.
That was amazing comment, because the three of them that I showed, they really go to hype to really establish technologies of open source. So again, good point. The other ones are not, it's still in the hype and getting off the hype. So again, good comment.
And to close out this live stream, if you have questions, if you want to talk to us or just have fun, just join us in our community Slack. And if you have technical questions, you can ask Marios and all that fun stuff. So yeah, do join our community, and it should be right below on the video in the description. All right. With that, Mateus, see you next week, hopefully.
Yeah.
To talk further about. Yeah, go ahead.
I'll see you tomorrow, actually, for the webinar, I think, 5.5.
Yeah, see you tomorrow.
Yeah, see you tomorrow for the 5.5. Yeah, you're right. Thank you, everyone. Have a great day.